So this class, like Chris mentioned, it's called Diagnosing Problems in a PACS Network using Software Emulators. What does it even mean? What are your guys' objectives in sitting here? And like, what were some of the reasons you guys signed up, signed up for this class? Any specific issues or troubleshooting problems or scenarios or things that you were hoping to take away that kind of made you say, I mean, let's put a mouthful of a title. Anybody have any input or specific issues that you were coming here as a result of?
Just hoping to become more proficient in it, you know, to make it to where I can do my job a little faster, a little better.
Really what we're trying to do is, in PACS networks and hospital networks, is trying to avoid this, right? Well, there really is no avoiding that. When I'm doing this, what am I referring to? Yeah. There's a problem sending the PACS, there's a problem pulling an image, the manufacturer says it's IT says it's the RIS, and everybody is pointing fingers. We're service engineers or managing service engineers and have to try and be in the middle here and have everybody work together. And these are tools that can help us kind of get down to that. If you look up the word emulate in the dictionary, anybody know what emulate means? What's an emulator?
The simulation.
To simulate something, to act as, right? So if you're emulating something, like you hear kids playing like video game emulators and Nintendo emulators and things like that, like you're emulating, you know, older video games on modern platforms. So to emulate is to act like something. So what an emulator is going to allow us to do is act like a device on the PACS network. You guys will get a copy of all the software that I use on here as well. I mentioned it before everybody got in here, but if anybody has a laptop with them right now and wants to download the software, you can actually install it. I'm set up to go through some demonstrations where I'll send and receive and do some practice stuff up here, but you guys can participate as well if you want to. I just added this a few minutes ago, so it is not on your presentation, but if you send an email to my email address, my out-of-office response has a link to download all these files. So just send an email to Boyland at RSTI.com. They'll all respond with a Google Drive link. They'll allow you to download all the files that I'm using during this presentation. So without further ado, so my name is Todd Boyland of RSTI for about 21 years now. RSTI, I see a lot of familiar faces, people that have been checked before that I've seen, you know, around the industry. Radiological Service Training Institute. We train engineers how to install, calibrate, maintain, service, and manage, you know, medical imaging equipment. X-ray, CT, MR, ultrasound, nuclear, and everything. I got myself in the industry early 2000s because of this. It happened. My degree is in computer science. I started at RSTI to learn imaging, and those two kind of worlds melded and worked well for PACS and troubleshooting. Is having some computer technology, computer background, and understanding modalities, and it really helps with this PACS troubleshooting. So our objectives for today, some things we're going to work on identifying the finger pointing issues that arise in PACS. Nothing is ever anybody's problem. We talked about IT, they didn't change anything. Then they call you back and tell you what's wrong, and all of a sudden it starts working, but they didn't change anything, right? It never happens. So lots of finger pointing going on, so we kind of have to be self-reliant on what we can do to prove a lot of these issues. So we're going to introduce DICOM emulators and some basic operations. There's a couple different ones to choose from. I'll give you, these are all free, by the way. These tools that are here, these emulators, they're freely available on the internet. You don't need to come to this class to get them. The issue is not obtaining them, it's knowing how to use them. And knowing what the logs mean, interpret the data that comes from them, which is really what this is going to be all about. We're going to use DICOM emulators to troubleshoot problems between systems and PACS networks, and then demonstrate troubleshooting techniques and logging. And this is really the key here is logging, because now we have sort of proof that whatever's going on is going on. So instead of going to IT and saying, I think this or I think that, no, here's what's going on. Here's why. PACS is doing this, and modality is doing this. Here's exactly what's happening on the network with no refuting it. And kind of tongue in cheek, but making troubleshooting techniques so easy, you know, no excuse not to implement them. So there's a lot of stuff in the weeds in this presentation as far as how the software goes. I'm going to try to make it as easy as possible. My job is to not make things complicated, it's to take something that is complicated and try to make it simple. So hopefully you guys can walk away with some knowledge and some tools that can actually be put to use in the real world. What about this? If there's any questions at any point, please stop me. What do we need to implement basic troubleshooting emulators? We need to understand what's called the client-server relationship. Many of you may have heard that before when it comes to computers, internet technology, client-server. In DICOM terms, we call that SCU and STP, service class user and service class provider. I'll talk about what the SPU and the STP means and how it relates to the client-server relationship and why that's important when we're trying to troubleshoot. Port numbers and DICOM listening ports. A lot of you out there have probably already configured DICOM devices before, just using all kinds of different port numbers. You probably know the default port numbers 104, but they can be required to be dynamic. They're static port numbers, but they're required to be configurable, so they may be something different. But 104 is the default, the ACR NEMA register, so you'll see that used quite often. We'll talk about AE titles, what they are, some limitations, rules, as far as standard, that kind of thing. And then what are called DICOM PDUs. Really, this is the weeds part of this class right here, protocol data units. And what that's referring to is every DICOM communication follows the same format. No matter whether you're printing an image, pulling a work list, doing storage commitments, sending an image to PACS, they all follow the same standard. There's these PDUs, which is the order that the communication happens when devices are communicating on the network. Protocol data units. Some things that we're not going to cover, we're here for 90 minutes. I can talk for 2 weeks on DICOM alone. There's a lot of in-the-weeds stuff, information objects, sound classes, transfer syntaxes. We're not going to get into that stuff. Real basic, send and receive. This will send, this will not. We're not going to go super crazy with DICOM. You're going to need to configure the device. And this slide, under important concepts, is the client-server relationship. It's important to understand what this is referring to when you want to troubleshoot anything to do with PACS. Everybody know what that means? What do I mean by a client-server relationship? If you guys are going on the web, yeah, there's always somebody requesting something. It's a handshake. There's somebody requesting something being done, and there's another device providing that something. Okay? Who is the person requesting? The client or the server? The client. Therefore, the server is the device that's actually providing something. If you are using the internet, what piece of software on your laptop are you using to search the internet? A browser, which could be what? Safari, or IE, or whatever. Is that the client or server? That's a client, right? It's the client software that allows you to connect to a web server, right? What's the web server? It's the port 80 device that's Google or Yahoo or the internet or whatever. The client device is the person requesting the information. The server is the device that is actually providing or sending the information. If you have the IP address of my laptop right now, and you open up a browser, and you punch in the IP address of my laptop in your browser, it won't work. Because that's the client. And yours is the client as well, right? So 2 clients can't communicate, 2 servers can't communicate. It all breaks down to the client-server relationship. Somebody requesting something and somebody providing something. Who always initiates the conversation every single time? Always the client. Because what do servers do? They just sit there and listen and provide stuff. So servers are web servers, email servers, PACS servers, and DICOM servers. They don't actively push stuff out. You just sit there and listen and wait for all these clients to connect. Hopefully you start seeing where I'm going with this, and that the PACS is the server. The RIS is the server. Modalities are the clients, the device that's going on trying to connect to these things. That's why this is important in PACS network, to understand who plays that role. And when you're configuring the software, you can be either client or server. And knowing which side of the role depends on what you're trying to accomplish in the troubleshooting. Port numbers and DICOM listening ports. So I don't want to risk the escape there and really this. But if you pull out your phone and go to, just do a web search for IANA, common port numbers. IANA, Internet Assigned Members Authority, IANA Common Core Numbers. Take a second. Searching your keyboard out. One of the first results that comes up for me is from IANA.org. Anybody see that one? So click on that IANA.org. This IANA Common Core Numbers.
Yes.
IANA Common Core Numbers, and one of the first results is from IANA.org, which is the authority that handles all registration of all these numbers. So, are there, is there a few of these core numbers or many? Like 65,000 to be exact. There's thousands and thousands of core numbers, 65,500. But for example, what's port 21 there? Go down that list and see if you can find what port 21 is used for. FTP, some of you may have heard that before, right? Transfer protocol. FTP is a protocol that's used to send and share files between devices. Has anybody here ever done any FTP?
Oh, yeah.
What program did you use?
Oh, gosh.
Files Love?
Yeah, you follow it, yeah.
FTP, all kinds of different programs. Is that a client or a server? But if you're using a software program that connects to a FTP, you are using a client.
Yeah.
Mozilla is a client. WSFTP is a client. Again, you couldn't use your FTP software to connect to my laptop. Because I'm a server, a client. Okay? So these are port numbers for servers. If your computer receives something and it's addressed to port 21, what does it know about the content of that data? It's FTP data. If your computer receives packets and the port number is port 21, what we're getting at is these port numbers tell the receiving computer what kind of information is contained in whatever's being sent. Some other examples you might recognize. What's port 80? So page 2 of that list, if you're on IANA, some of you probably don't know what 80 is. Port 80 is HTTP. Yep. So that will tell the computer that the content of the packet is web traffic. It's a website, it's web data, something to do with HTTP. Let's go to port 104 in that same list, which looks like it's on page 3, I think, on the same page I am. 104. Who owns the right to port 104?
Patrick Nima.
ACR and NEMA. ACR is the American College of Radiology, NEMA is the National Electrical and Mechanical Association. Guess who created DICOM? ACR NEMA. So, and DICOM was originally developed in 1991 with the first revision. Actually, it was in 85, it was the first revision, 88, second revision. In 91 was the third revision. They changed the name ACR NEMA to DICOM because ACR NEMA promoted more American, ACR, the name. Where DICOM is really was designed as a global international standard. We're Germany headquarters. Of course, where Siemens headquarters.
Germany, you already gave the answer.
Yeah, GE is in Waukesha, Siemens is in Germany, Philips is in the Netherlands, Shimatsu is in Japan. So the idea was a global international standard. And it may sound silly, but if you guys write the date, what's today's date? How do you write that? Month, day, and year. Well, the year are they right? Year. It can be year, month, day, or month, day, year, depending on where you go. So the whole point of DICOM is to take all of this standardization, all this data that is, shared amongst manufacturers, amongst devices, and standardize it. That's what DICOM does. But 4104, I just wanted to see, is registered to ACR NEMA, because they're the ones who created this and set the standard for DICOM. The next slide here, and if you're following along, I am on page number 3, slide number 6. In DICOM, we don't call them SPUs and SCPs, we call them service class users and service class providers. And who initiates any DICOM communication? We're going to talk about this on client, right, every single time. So the SCU is the client, the SCP is the provider. In an example, if I'm sending an image to Curtis, right, I'm the modality, he's the PACS. Who's providing the storage? If I'm sending an image, he is. So he is the server, he's the SCP, service class provider. I'm using the storage service that Curtis is providing. Does that kind of make sense? So in a DICOM standpoint, everything we do, risk, work list, storage commit, print, everything is done in this SCU, SCP relationship. Who initiates it every time is the SCU. The SCPs are just servers. They're PACS, they're risks, they're work list, the devices sitting on the network, waiting for an SPU, waiting for a client to talk. You probably have heard of AE titles before, right? AE stands for application entity. It's part of the DICOM standard, which names the application entity. Application meaning software, right? The entity is like a device. So the AE title is basically just a software name for a device. There are some of the rules when you're assigning AE titles. Why am I going through this? Because if you're going to use an emulator, you have to assign AE title, you have to assign a port number, you have to assign IP address. They're all things you have to configure. If you've ever configured a device on a DICOM network, you always need 3 pieces of information, right? What do you need? IP, port, AE title. At a very minimum, you need an IP address, an AE title, and a port number to configure any device on a DICOM network. So these have to be unique within a LAN, so unique to the hospital, no spaces, they're case sensitive, and 16 characters is the max. Questions about that?
Y'all get that?
We're done. More if you touch this for more than a millisecond, and that happens. That's it. Okay, on to the next slide. The two principles of transferring medical images, we have, networking and DICOM. Networking are the rules and the protocols for TCP/IP. DICOM does not deal with IP addresses or anything to do with the network. It's really, the whole point of this slide is DICOM is not a protocol to send data on the network. TCP/IP does that. We rely on TCP/IP to get the information from point A to point B. DICOM is just a structure of how that data is organized. I gave the date example previously as an example of that. So DICOM is just a set of rules and regulations that standardize the format of the data. We still rely on TCP/IP to get the data from point A to point B. Why did I mention this? Because if you can't ping something, DICOM is not going to work, right? You're probably all aware that the network has to work fundamentally first. Hardware, the switches, the backbone, that doesn't work. None of this stuff works. So don't worry about troubleshooting any of this port number, AE title stuff if you're having hardware communication problems. I know it's hard to see because this thing is kind of small, but PACS, digital imaging components, what do they consist of? The term PACS is kind of a slang, right? It stands for Picture Archive Communication Server, but it's really kind of all-encompassing. When someone says PACS, they're really referring to all this stuff, right? Long-term storage, short-term storage, HIS risk, so that would be patient demographic and modality work list information for scheduling. ADT, or HL status, be a broker for admission, discharge, transfer communication. Those kind of work together with HIS and risk. Printers, there are still some facilities out there that still want to print. Orthopedics, some manual facilities still use the printer. Do you guys have sites that still use printing? We can bring your paper around and do forms.
Dude, I've got sites that are using film.
What modalities?
Like a doctor that has like an urgent care kind of place or whatever, is an old guy. He's having a hard time getting chemicals.
Yeah, it's really nuts. Yeah, it's still out there.
Especially in California, right?
Oh, yeah.
So the printers are all part of this. The workstations where the docs are doing their interpretation, the radiologist workstations are doing their dictations and creating the reports. All these are components that are part of this PACS network. And obviously the modality is what's acquiring. Could be a CR, DR, manual, ultrasound, I mean, you name it. Every single modality that exists has the capability of sending and archiving information. Even if it's not an image, the big push now for dose reporting. Everybody's really dose centric. We want to store our doses and dose reports. There's no images in there. It's just data on doses. I still DICOM. So everyone thinks of DICOM as an image, like CT or X-ray. But dose reports are a good example. They're DICOM files. It's standardized that reporting, but it still gets into PACS. That kind of makes sense? Does it have an image? All right, what slide is this on?
9.
Slide 9, page 5. This is a really important concept. I know it's hard to read, it's kind of tiny. But how does all this stuff work? Two devices create association. We call them AEs, application entities. There's a negotiation of what services can be performed. Okay, I can print, store, work list, they're negotiating all the capabilities that each device has. Then the requested services are performed, which means the images are sent, the films are printed, the work list is pulled, then the associations end. Think of this like a phone call. These devices aren't communicating 24/7 on the network. They only talk when they want to do something, or share something, or say something. Right? The SPU is always sitting there like this. So the FTP, the server is always sitting there listening, and the SPU just says, okay, PACS, I want to talk to you. What can you do? Here's what I can do. It's kind of like two people that want to communicate. Well, I can speak English and French and Spanish and German. This person can speak English and foreign languages. We'll have to communicate in English. So they're establishing these rules for what they are capable of doing. Then they're doing that thing, whatever it is, and then the associations end. They go to their phone call. Pick up the phone. What should you do? Hang up the phone. This slide gets into what are called diagnostic services. What does SPU stand for again? Those slides ago, I had SPU and SPP. Service class user and service class provider. So that name, service class user and service class provider, this is where it came from. These are the service classes that DICOM supports. Okay? So if a device supports DICOM store, it's pretty straightforward, right? It's used to send images from point A to point B. What's query retrieve used for?
CRES.
That
Yeah.
Stores?
So this is more of a push.
Yeah.
What would this be? Pull, right? If a doctor sits at a view station, or a doctor wants to get a CT study at their workstation, they're not going to walk the CT and do a DICOM store to the workstation. They're going to sit there and do a query of the PACS and then pull from the PACS. So this is more of a pull function. But why is it called query and retrieve? Because they're querying for, show me all the CTs that were done on this day that are unread. That's the query. And the retrieve is clicking Jane Doe's images, and now that one image comes. Who initiated that, the query retrieve? The workstation or the PACS?
The workstation.
Workstation. Exactly. So it might be kind of confusing, but the PACS is still providing that service. The workstation is the one that's using it and initiate that conversation. Print is pretty straightforward. The printer is the provider. The device that sends to the printer is the user, the SCU. Modality work list is the name of the service. You also hear this called RISP, Radiology Information Service. This is the confusing one. How does the work list get to CT, for example? Anybody know?
Well, from the
Is it push or is it pull?
Well, it's, you query, you pull it, right?
From what?
The work list server.
Part of the
task.
doesn't sit there and look at this.
No.
The RISC does not push the work list out all day long. What happens instead? I guess for the requested.
Yeah.
So the work list provider is the RISC. The work list user is every other device. So I don't know if you knew that about the work list. The RISC that has, you guys know what a work list is? What RISC is? It's a database of all the patient scheduling information. Jane Doe, John Doe, procedure information, CPT codes, all the stuff they would need for scheduling and for billing. Well, that's stored in the central server. It's not pushed out to all these modalities. Modalities have to request it. They may auto do that every 15 minutes or 10 minutes, but still request. Refresh every 15, refresh every 15, you know what I mean?
That would be the ADT server.
If it's a broker that's converting, then yeah, your ADT would all be part of this. Exactly. The thing about ADT though, ADT is not diagnostic. So ADT, what he's getting at is HL7. The HL7 data is more clinical data and billing information, just health level 7 for like admission and discharge and transfer. That's not DICOM, so a broker would convert HL7 data to DICOM. So technically, the work list provider would be the broker, because it's the one that's provided that conversion. Does that kind of make sense? Good ones. Another service class you should use is what's called DICOM verification, right next to this.
Yeah.
DICOM echo. Be a very important one for this next hour. And verification and DICOM echo commonly get confused with ping. What's the difference? What are you using ping for?
Ping is
basic.
Yeah.
Yeah, ping is checking nothing medical. It's
Right.
only the network, it's the hardware, IP addresses, that kind of stuff. DICOM echo is what does the handshake.
Yeah, right.
You know, this is a DICOM echo. You could have ping succeed, but none of this works. Now we have solved the problem. Right? So what ping and echo allow us to do is differentiate hardware versus software and content issues that kind of thing. I'm not going to get into MPPS, it's really too advanced for this time, but without a performance procedure step, we'll send updates back to the RIS, for example. If the CT study gets done, it will send a message to the work list to pull John Doe's CT off the work list. So it's automatic updating, things like that on the work list. It's complicated, not let's use it for that reason. We are now up to slide 11, page 6. This is more of a graphical summary that we just talked about. When talking about document store, we're talking about sending an image. So it makes sense that these two devices are the providers, right? Why would the workstation need to be a provider? I thought a minute ago, I just said the workstation is a query retrieve FTU. Well, yeah, agreed. How do you even get here though? Could they come from here directly? No, sure. If that's the case, he needs to be a storage provider. If the image is only being pulled from here, then he is the query retrieve user, and this guy is the provider. So it all depends on the workflow, is what I'm getting at. Every site's different, facility is different, but you will typically, manufacturers will build those features into these systems because they don't know how the customer's going to use it. Kind of follow me?
A lot of they don't like storage.
Correct.
Because security reasons.
Yeah, and these hard drives aren't really designed for that part. I mean, you might have a couple of terabytes of storage in here, but this is all for storage, right? So, but even with that being said, there may be an alert link on here that says, hey, get rid of everything that wasn't used in the last 30 days. So that the image still could get here this way, or it could get there this way. It depends on the workflow of the facility. So DICOM store, if I want to send an image from here to here, what role is this workstation playing? Server, the provider, right? If I want to send an image from here to here, what image is this? What role is this playing? Why would the PACS ever need to be an STU? What's an instance where the PACS needs to send images somewhere else? Think of anything?
We send it to others.
Off-site storage, different facility, long-term storage, backup solutions, all those things. So yeah, the PACS is trying to but there's instances where the PACS needs to send images somewhere else, and there it would be an STU for that particular home conversation.
Really fast.
Really fast. DICOM print, pretty self-explanatory. The printer is the provider. Any device that wants the print is the user, is the SCU. Query retrieve, you've already went through this. the PACS is providing the query retrieve. And a lot of modalities will support query retrieve. CT is one of them that does often. In this example, I made this one, but it's arbitrary. It could be whatever. But based on this scenario that you see right here, there would be no way to get an image from here to here. How come? Based on what you see here, you could not, if you delete an image from here, there'd be no way to get it from the PACS or the workstation back to the CT.
Because it's not a
It's
provider.
not provided. It's only applied. Yep. Again, a lot of them will have the capability, but I'm just saying based on this exact scenario. Work list provider, work list user, client server. Does that make sense? That works, right? That's good there. We've already mentioned this. What do you need for DICOM communication? You need at least an A title, not full address, and a board number. I put subnet mask in there because it's something you want to know, because if the subnet mask isn't correct, that can cause the device on the same network to not communicate. So it's something you want to make sure, at a minimum, it matches the two devices. A title, IP, and board number. And who generally keeps all of this information? Usually IT, PACS department, it depends on the facility. You know, if IT and PACS are integrated, it might be its own thing, PACS might be its own thing, but somebody in IT or PACS should have all of this information. You guys are probably all running the small facilities, first like customer, maybe smaller customers where there's no one in this.
Yeah.
Now you got to figure out what's the IP of this, what's the A title, what numbers, digging around settings, finding stuff. But hopefully the customers are keeping track of this in a minimum spreadsheet or something, you know, along those lines. What services do we need? This is DICOM store, again, SCU, SCD. Already went through all this. Query retrieve, or query retrieve SCU, query retrieve SDP, that's pulling the image back to the modality. Work list. The REST is the provider, the modality is the user, again, because modality is the one initiating the conversation and querying the devices. We have modality, which is the user, print user, sends to a printer, provider, SCD. Now, modality verification, which we call DICOM verify or DICOM echo, the modality sends the handshake, no actual information is exchanged, no images are stored, no patient data is exchanged. It's just a handshake. Hey, Curtis, can we talk? Yes, we can. That's all that happens. But if this DICOM verification or DICOM echo works, what does it tell us? Even though no information is actually exchanged hands, they're configured properly. Yeah. The hardware is good, they're communicating, and the software is configured properly. Because if you can ping but can't echo, is it a hardware problem or a software problem? You can ping but can't echo. It's a software problem, absolutely. If you can't ping, it's probably a hardware problem. You have hardware or something like that. But that really helps isolate these. And DICOM echo, when it works, the A title is configured right, the port number is configured right, everything is good. So think about this. What if the echo works, but sending an image to PACS doesn't work? What that for a second. Can't be echo, right? It's not a configuration problem because the echo succeeded. So what did I say echo does? The handshake, but doesn't exchange any data, no data. What's DICOM store doing? Sending an image. Give me a reason why a PACS would reject storing an image.
Overfull, or, yeah.
What's that?
If it's too full already or
Could be
something.
storage issue.
Yeah.
Could be out of memory, or it could be out of hardware storage. That will happen. What's that? Could be something wrong with this specific file. Absolutely. Anything else? Yeah, those are all great reasons. Something wrong in the actual data. How do PACS keep track of all this stuff? There's a database on the PACS. Well, what's the unique identifier that is going to be used? Every hospital has one, right? patient ID, there's like soft flash UID, all kinds of IDs. Is it reasonable to think that a PACS might reject an image if it was missing a patient ID? It wouldn't know where to put it. It doesn't know where to put Jane Doe's images. So in that case, would the echo work?
Yeah.
But the store failed. So what that's telling you is you have a content problem. That makes sense? So ping is right here, hardware. Echo is configuration, and the rest is content. So if you can do all these handshakes and all this stuff works, I have a problem with this image, pressing a different image. Maybe the word list was down for the past hour. And guess what? So we're back to patient ID. They do it manually. They're not used to doing that kind of stuff.
Hey, with the tactic, that in the size, do you get the, with the right way?
No, that's all configured in the handshake. Yeah, that's all agreed upon before and then that. It wouldn't do it because it's going to happen in the handshake. I'll get to your question in a second. When they actually pick up a phone call, they negotiate all that stuff even before the image is sent. Here's what I'm going to do.
We in here latency, like a switch, or hardware switch, has latency.
There could be timeout issues, and DICOM has built-in ARRT timeouts and they're called. They're configurable, and you see that in logs. Because you see the STU do something, and the STP should respond right away. If they don't, I know that the STP got it, and there's some kind of latency on this end. But yeah, there could be timeouts and latency issues as well, but those are more hardware and network type problems. All good questions. Okay, this slide here is the big one. Oh, you know what? Sorry.
Yeah, we don't have that.
Take a note, sorry. I put this in there, so I realized it was missing. So after, put this on page like, yeah, exactly, page 17 and 18. PDUs, protocol data units. DICOM PDUs, protocol data units. So every PDU1 is always an association RQ. Any guesses what that means? Request association. A PDU1 is an association request. What's a PDU2? Association of knowledge or access. What's PDU3? Association rejection. Would you ever have a PDU2 and 3 in the same message? You either accept it or reject it. So when an SPU sends something, the STP is either going to respond with one of those two things. PDU4, it says data. This is where the actual DICOM information is communicated. So PDU4 data, DICOM information is communicated here. What's happening in PDU5?
They're basically telling the one who requested a date, good to go.
Yeah, okay. Hang on with that. What's happening in PDU6? Sure, okay. Good. In 7 is rarely used, or you'll see once in a while if something is canceled. So think about this. Who always sends a PDU1?
User.
Always the SDU. So this will always come from an SCU. Where's the PDU2 going to come from?
The provider.
Provider, every time, the SCP. About PDU3? The provider, every time. PDU4 will go both ways. Store this image? Yes, I will. print this film? Yes, I will. This is the actual, request this work list, here's the work list. That's data that's happening. So 99% of all the stuff we're working with really happens in here. This is just setting up the handshake, and this is closing the handshake. This is the actual, the meat of the transfer. Okay? Who would send a PDF file? STP or STP?
That's the
STU. How come? Because only the user knows when they're done.
Oh, okay.
Right? The STU is the one that's wanting to do something. Better to know.
Yeah.
If here's 1, 2, there's 3, there's 100,000, it doesn't know when it's done. So PDU5 is the STU saying, okay, I'm done. Let's hang up now. PDU6, who's talking there? The provider, okay, sure. So all that probably, I mean, it sounds complicated. Yeah, that was a big risk right there. Shit.
So I had a real good one just recently. I had a Hologic Selenia that I was adding a work list to. It could echo, it could ping, but no data. Never give data. And chased my tail for a good hour on it before I found out that their whole HISPRIS system crashed. And it crashed exactly when I was in there adding the new work list. And so
What'd you do, Chris?
well, they blame me. They blame me. They said I took it down. I was like, your work list must be really weak, man. Your security.
I pinged your work list, I took it down?
Yeah.
Yeah. Okay, so.
I lost the video now, is that right?
Now you gotta draw.
Oh, great.
Put that full screen. Yeah, you gotta write all that down. Stuff. Yeah.
All right, I hate to do this to her, but I need to stop this recording then because this kind of is important.
Some real electricity.
Yeah. Okay, so this class is about emulators, right? One of the emulators that I'm going to recommend is called Diagnosing. I'm going to be passing around, step-by-step instruction sheet of how to install this and configure it. Again, if you email my email from the first slide, we'll get a link to download all the stuff, and then we'll walk through it. It was close this morning for me too. If you don't, you'll have my email. I'll respond to them all when I get back, and I'll make sure I send it to you individually if you didn't do it. So this is the emulator software. This is called J.com. It's a software we're going to use. This particular one is called Image Server. What am I acting as right now? STP, Image Server. And there's a lot of stuff here. It looks intimidating. I really only need to fill in the top 2 fields. Can anybody see that far?
Yep.
What's the top field asking for? Port number. The second one
Is what you are. You're
call title.
Yeah.
So that's a title. So a titles, there's always a call and a calling. Which one's the SCP? Yes. Call. You're gonna phone conversation. If I'm calling you, you are being called with the provider. I'm the SCP, I'm doing the calling. So I'm going to leave calling blank because I want to be promiscuous in this case and allow any SCP to communicate. Why am I not setting an IP address in here? Where's that coming from? Windows, right? I can do an IP address. So I'm not telling the emulator to use an IP address. It's going to come from Windows. It's the server. So there's a command that I'm going to get to. It's in the slide in a second here. You guys have all pinged before. There's a command called netstat. Some of you may have heard of. It stands for network statistics, and it shows open port numbers. So I know you guys probably can't see it, but local address, there's my local IP colon port numbers. So port numbers follow the IP. You may have to take my,
Constantly updates?
yeah, it's slow. Yeah, it's slow. Notice port 104 is not open. It goes from 135 to 445, it's all numeric. Why is 104 not open? There's no software on my laptop right now running PACS. So I'm gonna turn the emulator on. This image server GUI, I'm gonna hit start. What's it say down here at the bottom? That's hard to read.
Waiting for.
Waiting for invocation from clients. What does that mean?
He's active and listening.
I'm ready. I'm just sitting here listening, okay? So it was that simple, setting up the SCP.
So now 104 should be on that.
Exactly. Now I do the netstat again. And look, I have 104, it's a word for it. What's it say? Listening. 404 is listening. So what caused that port number to be opened on my computer? That software. So the software running opens up that port number, and now it's ready to receive. So effectively, my laptop right now is a PACS. It has an IP address, has an A title, has a port number, you can send an image to it. So here's the other side of the modality. This is another program. This is where I have you guys the other half, right? Storage SCU. Host, what goes in there? The IP address of the SCP, in my case, I'm saying to myself, so 127.0.0.1 is the loopback address. Probably you've heard that before. Basically just send to myself. Port number 104 means address all this data to port 104 so that the receiver knows it's PACS. Call title. Store SCP, that means the SCP is going to be this, and the STU is going to be this. I'm going to now hit connect. And look what happened here. On the SCU, what happened? J.com, store SCP, associate RQ PDU.
So it said, hey, I'm so-and-so, and he said, yep, I know you, and ready to talk, but no data is going across.
Nothing's happened so far. So who was talking in this top one right here?
Well, that's the,
User.
the
user. The second one, associated acknowledge or accept, is the PACS to do that. And you see it back here as well. This is the weird, it's that two open, right? Down here, but it's it worked. So I haven't even echoed yet. All I've done is done that handshake. Now, what PDUs have happened so far? Go back to our PDU list. 1 and 2. So that's PDU 1 and PDU 2 right there, right? Now I hit echo verification request, verification response. What PDU would that be?
5 and 6.
No.
Oh, no, that's release. Never mind.
One.
No, it's back to 1 and 2 again.
That's 4. That's data.
Oh, that is data.
That's not actually part of the handshake. The handshake was already done.
Oh,
Okay, hey Curtis, you out there? Okay, I'm there.
So the echo is actual
The
data.
actual is data.
Okay.
It is not sending, it's not sending images, but it's in the data portion of the communication.
Okay.
Does that kind of make sense? If I wanted to send an image, I could do that now. I click send. And let's see if I have any images on here.
Dirty ones.
And keep it clean here. You know, I wasn't prepared for this, to send an image. But let me go ahead and hit release.
Oh, that's cool.
So this is the document echo. Normally you just click echo and it happens like this and get you a check mark. This is what's happening behind the scenes though. PDU, what is this? PDU, PDU 1, 2, 4, 5, 6, and done. So, okay, how can this help you? Just notice what you have done right here. If you can't send an image to PACS, you can set your laptop up as one of the two and at least see who is doing what. And the cool thing about, watch this software, the default, this is all my instructions too, by the way. Verbose, this is log level detail. I was on 1, which is basically bare minimum. So watch this. So I went to level 3.
Yeah, way more than you need.
And this started here.
So, privilege is terrible. Association requests, call title, calling title, max PDU size, timeouts, all those are parameters that are set up in this PDU1. These unique numbers here, if you Google these, CT image storage, MR image storage, ultrasound, nuclear, radiation dose therapy, blah, 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 blah. These are all the DICOM capabilities that one device has. Who is talking so far that I'm only the SCU. So the SCU said association request. Here, and here's how I will do it. This size, this timing, all these settings. Has the SDP even said anything yet?
That's as big as that thing.
Yeah, because they need to move the whole thing back, and the power cords are the limiting. Believe me, I tried.
Yeah.
So who's talking here? Still SCU. Again, I know it's hard for you guys to see. One of you guys mentioned before, little endian, big endian. I think it was you.
So here, he's saying, I do enhanced SR, little endian. You know, CR images, JPEG, CT, ultrasound, little endian, big endian, lossless JPEG, compression. All of this stuff is negotiated in advance. Has the SCP even responded yet? So this happens every single time there's a DICOM communication, whether you're doing echo, sending an image, pulling a work list. After PDU 1 and 2 have established that handshake, it's wide open. Big and open. It's not like, hey, here's an image, and they're stuck to that image, nothing else. They're configured to do everything every single time.
So here's the SCP. Again, I'm sorry, SCU. I can do this, 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 I can do
That's a
this.
little narcissistic.
Yeah. Finally, I get down to here. Everything above
What I've highlighted is part of which PDU. This is PDU 2. Only PDU 1. And now, we have association AC. What would that be? Acknowledge. So now, who's talking here, SC or SCP?
Keith.
The SCP is coming back and saying, I accept your PDU size. I accept your timeout settings. I accept your A type. Oh, low ending, really explicit, implicit, you know, compression, JPEG, lossless. I accept it using this format.
Oh, wait a minute.
And down here, unsupported abstract syntax, which basically means stop class, and I'll get into that. This just means there's a feature that the PACS doesn't support. Like maybe this is a brand new 3D Tomo mammal, and the PACS is 15 years old, and Tomo mammal didn't exist 15 years ago. Does that mean these two devices can't communicate? No, but it means they can't do Tomo mammal together. They can still do VR image storage, or regular 2D mammal, or verification echo, that kind of thing. That makes sense? This is not a failure. This is just an SCP saying, okay, I can do this, 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 and this. If I can't do that, I can't do that. They can still talk. What PDU is this right here? 2. All PDU 2. The SCG coming back and saying, yes, I will accept that.
I haven't even sent anything yet, right? So here's an echo.
Echo request, echo response. PDU 4 and 4.
I hit release. Right, and there's your 5 and 6, right? So really, if you take nothing else away from this, that is important, that PDU thing. Because that's how, you know, when you go to your PACS or your workstation, your modality, or your emulator, the logs may look a little bit different, but they're all going to be in that format. If you can understand those PDUs in the emulators, it makes it way easier. This, I heard you guys mention before, something about DICOM header. This is the actual header data of a sample image. So every DICOM image, this was a map, has the actual picture, which is the image data and the pixel data, and then the DICOM header, which contains what, like demographics, date, time, who, what, where, when. All that stuff is stored in every single image.
A lot of that.
Yeah, tons of
That's quite big.
Yeah, well, relative to the image, it's really small. What PDU would you find these in?
So this is gonna be, there's gotta be more.
Because you said, CRES is for data.
Yeah, the actual data, all the tags would be in
Your emulator pulls all this up. Your emulator pulls all this up. See, that's nice because when you have a tech that's complaining about image quality or something like that, you can go in and see kind of what techniques they're using.
You can tell a lot of stuff.
Yeah. Yeah, you're not gonna get a shot at 50 KB.
Go to. Should I include this? Go to page 25 here, guys.
Ooh, we're almost done.
Jump ahead. Oh. Take the pencil or the highlighter of your pen and circle where PDU1 begins on page 25. That'd be a pretty easy one. First line. See where it says PDU type 1? And then right below it says association request. So maybe just circle association request for PDU1. So you kind of recognize that PDU1. Show me where PDU2 is. So you guys can find PDU2 in this log. Association acceptance probably was at 12 or 15 lines down. You guys see that? PDU2. See if you can find PDU4. It's right in the middle.
Data set file.
Yeah, data set, PDU4. And this is in the weeds. Do you guys see those DICOM tags right there in the middle? Right here. Has anybody ever seen DICOM tags that start with 0 before? Probably haven't. So here is a DICOM header I showed you guys. What do you know about these numbers? 8, 18s, 24s, 28s, they're all positive numbers because the data in DICOM, the tags, is stored in positive numbers. Commands are zeros. So you don't really need to know that, but basically this command set right here is saying store an image. So basically just draw a circle right in here with all the zeros, all the zero tags right here. And make a note that says command to store image. Command to store image. All of this right here. Zero stuff.
That's a
Command to store an image.
the USB anything?
Just be unsigned signature, so it has to be positive, US unsigned. Go to page 26. Now, the bottom quarter of the page, what do you see there? Those are all tags.
Oh, yeah.
See all the 8 tags? Then go to the next page. All the 8s, 10s, 18s, 20s, 22s, 28s. So who's talking right here? SPU or SCP?
SCU. The SCU said, I'd like you to store this image. We haven't even heard from the SCP yet, if they accepted it. So go to page 28. Find the next PDU4. Highlight or circle where it says PDU4. I'll give you a hint, it's in this area right here. PDU.
1.78.
And then look for the command, the tag 0,900. Does anybody see 0,900? In DICOM, that's the status field. So draw an arrow to 0,900. That's the status field. In a DICOM, 4 zeros means success. So the status field of 0,900 should be 0,000 if it was successful. Was this successful?
Yep.
Look carefully. B000.
Oh, on the other
It
side.
looks like a 0. It's actually a Bravo. Bravo 000. Do I see that in the status field? Right below there, the next tag, it says set instance number to 0. So this failed because the instance number was missing. Instance number, but there's a DICOM tag up here somewhere that's called instance number, and it was empty. And the PACS said, I can't do that. They rejected this image for that reason. But my point is, it tells you that. I know you wouldn't have known to look here. You know, but the whole point of this is understanding these PDUs. If there's a problem, you know, really, when I make troubleshooting, I go to 0,900. Because 0,900 is the status field for everything. If it worked, what will be in there? 4 zeros. If it's not 4 zeros, something is wrong, and there's going to be clues below there. Often they'll even give you a tag number. Like in the next line down, it'll say like 8,30. If the study date is wrong or something like that. What PDU is all this part of? PDU4. Who was saying it though? User or provider? The provider, because the user doesn't know if it was successful. Only the provider can know. That's the handshake, right? PDU1, PDU2, PDU, everything's request, response, request, response, request, response. And then at the very end, sort of PDU5 and PDU6. Actually, I don't see a PDU6, I see a PDU5. Yeah, there should have been a 6 below there, so you got to cut off. What he said.
Yeah. Somebody pulled the network cable out on it. All right, so we got about, what, 20 minutes here? Let's get into some of this meat and potato stuff here. So let's go back to whatever page this was right here, 19. This is just saying, make sure TCP/IP works first, because all this is moving to it doesn't. I have a note here about the firewalls with that.
Because they suck.
A firewall could give an indication you have a hardware problem, but really it's firewall blocking. So don't just ping one device, ping A to B, A to C, A to D, A to E, ping the router, ping something you notice on a firewall to prove that, and go from B to A, C to A. You know what I mean? You got to hold the at make sure the firewall isn't an issue. We talked about NetStat. I already showed you NetStat -A for the port numbers. Understanding ping and echo. What does a failed ping tell us? Hardware problem. What does a successful ping but a failed echo tell you? Software configuration. What does a successful echo tell you?
You have
It's
communication.
configured right. You have configured them right. Yeah, exactly. If it fails beyond this, Now we have a content problem. Like we just saw there, that study instance number was missing. In the DICOM tag, it said set instance to 0. That's because it can't be empty. 0 and null are two different things to a computer. Right? A null value is empty, and PACS says I have that something, even 0 is something. So it told you, put 0 in there, give me something. So I accept it.
Because null and 0 are not the same thing.
So when you send DICOM echoes from modalities, they may not be available, and the results are often non-intuitive. This one is actually pretty good. This is a GEDR. This is like a Definium, Discovery, Optima, modern GE digital x-ray system. You click the device, you click see echo test, and it says success. Great, pretty easy, right?
The next slide,
This is from a GE manual system. You click the PACS here, and you click test selected host. What is that actually going to do? What does that mean? Test selected host, I have no idea what that means. I didn't know until I put an emulator, an SCP emulator, this was an echo. So this is the doing a DICOM echo, but when I first saw this, I was like, hey, the point is, the interface is often not very intuitive. So even if you have access to it, half the time you're like, oh, I'm doing it.
Probably.
yeah.
This is from a Philips digital diagnostic. This is a pretty good one because you pick a device and it says ping, checkbox, network, checkbox, verified. But now that you know that verify is actually a DICOM echo, it's showing you all those results.
And what slide is this one on here? Do we have this slide on next page? Okay.
So the two emulators down to the business. The two emulators I recommend. What time do you want to? Is it 12? It's 12. It's 12. So there's two emulators that are pretty popular. JDICOM and DDTK. I recommend JDICOM. It's older. It's no longer supported. Meaning you're not going to have structured reporting, dose reporting, really crazy, new modern 3D stuff in there. Most of the stuff for troubleshooting is just simple ping, wordless echo stuff. So this works really good. It hasn't been supported since XP, but that's what I was using right there on my Windows 10 system. So the bottom line is use JDICOM until it won't work anymore, and then switch to DVTK. The thing I don't like about DVTK is you have to install each program is an emulator. Storage SDU is a program, SDP is a program, print, Word, they're all separate programs. And you have to have definitions to upgrade them, update them in modern DICOM. So the advantage of DVTK is it is being released and upgraded currently. But again, for troubleshooting what we need to do, this is really much easier
And can do everything we need it to.
You don't need to get down to be the PACS guy level.
Yeah, exactly. I'm going to jump ahead here. Let's go to this page here. So you can flip ahead a couple pages, guys.
16.
Page 15, the slide 30. It's the same with no picture. Slide 30, page 15. So how are you going to use this information when you go back? You're going to install the software and you're going to emulate an SCU or an SDP. So what we're going to do here is if you want to emulate the SCU. So what would you be doing there? Why would you be emulating SCU? Now, a couple of problems have, right? You want to send an image from your laptop to the PACS. If it works from your laptop, but didn't work from the CT, what do we know? Everything over here is good, the top is over here. Well, then flip around and do the SCP and go from CT to our laptop and test it, look at the logs and check it out, right? So we can kind of do both ways. So I'm going to set up the SCU to send the PACS. Do you just make up sending? What should you use in here? For like IP, AE, port number?
What you've been provided.
But you weren't providing anything for emulator.
That's true.
In fact, IT probably said, no, you're doing this, they probably wouldn't know.
Shutting it down.
for, you know, forgiveness.
Yeah. So basically, I would copy whatever their provider is or whatever that.
Yeah, use these settings.
Yeah.
Use the IP of your core that are in the CT. Why can you do that? It's unplugged.
Yeah.
So the other thing is most PACS aren't promiscuous. So they would not like a new A title or a new IP coming to you.
Yeah.
The PACS still may not like your MAC address, still may filter, but at least you're one step closer. So you plug in your laptop, you set your laptop up with the same IP as the CT, the same port number, the same A title, all that stuff matches the same. Make sense?
So I've had a couple slides, actually,
That might not be on there. Is it on there? 33? 33, okay. Before you guys leave, so I put like a summary in here of the setup and the configuration. I have a really granular step-by-step that walks you through installing and configuring both with Diagnosing and DBTK. So before we leave, if you guys want, you can come up and grab those. This is just kind of a 10,000 foot summary level. This is really detailed, and we'll help you get through it. Basically, you would set that IP address, run storage STU in the properties tab that you just saw me do. IP address, port number, and the AE titles can be confusing, but call and calling. Think of a phone call. The STU is the client. The STU is making the call. The provider is receiving the call. So Diagnosing always calls them call and calling. So keep them straight. The verbose, you saw like verbose 1 was just PD 1, 2, 4, 5, and 6. Verbose 3 had way more stuff than you would want, and you can click and answer. And now the log should read, in the log you can see this. If you see this in the log of the emulator, you know. An association was requested and was accepted, acknowledged. Yep. Then you click on echo or send an image and you see this. It was configured right and it's working, and look here. Remember that? 4 zeros, always successful. Even totals right here. Okay, that goes good, successful, great. Then you click the release button and you see these. What's happening there?
I'll see ya.
Yeah. Can I hang up? If you can, okay. But in reality, in the real world, all of this stuff happens at once. It's like 1, 2, 4, 5, 6 right here. The emulator has you click the buttons for connect, echo, release. All that stuff is happening on the fly if you watch this real time on a real PACS. The next couple slides go through DBTK. I'm not a fan of this program, but I included it in there because it's updated and it's Windows 10 compatible. So you have instructions for it. Let's go to this slide here. Is it a couple slides ahead? 36. Slide 36. Okay, page 18, slide 36. What PDU would this be? PDU1. PDU1. What would this be? What would this be? This one? 4. This one? 5, 6. Why don't you see the 0900 tag anywhere in here? Who's talking? Client. Remember I said 0900 before? What's that tag used for? Status code. Why don't you see that in the actual request? Yeah, the user doesn't know. That would be the provider side. Does that make sense? Mm-hmm. The SCU is requesting something. The provider is the only one that knows if it worked or not. So the status code I mentioned before is only going to be in communications coming from the provider. Does that make sense? Okay. What PDUs do you not see in here? 7. 3 would be here. That was a reject. And 7 was an abort. So in summary, every single successful DICOM communication has what PDUs?
1,
2,
4,
4, 5, 6. How about its modality work list? 1, 2, 4, 5, 6.
So it's the same.
How about query retrieval? 1, 2, 4. So, if you understand the standard in the communication of these PDUs, everything, no matter what it is, operates exactly the same. The PDU4 is going to change, because that's where print, work list, store actually happens. But most of the time, we don't care. We just need to know if it worked or not. I don't need to know, what KB was used or what patient ID was. That's all going to be in the data report. Exactly. And you have varying access to logs. Every system does this, but you don't see it because you have varying access to logs. Your PACS administrator should have access to logs like this. They probably don't know how to read them, is the truth of it. But there are some kind of logs that break down like this. The cool thing about Emulator is you can do that, and it will give you that, and you can show it to people. Oh, look, here's this PDU, here's that PDU, this happened, this isn't happening. It's on a piece of paper you can print and send somebody, and you can't refute it. No. Let's jump ahead here, a couple more pages to this one. We're going to emulate FQP now.
Page 20, slide 40.
What are we doing in this scenario now? Now we're acting as a what?
called the
PACS. Where before, we were acting as a modality, sending PACS. Now we're acting as a PACS, we're going to receive. So what do we do here? I plugged into just a network, local network switch. Why am I allowed to do this? Because normally you plug in a switch to the network and IT is going to have a busy bit, right? It's unplugged the wall. So you unplug the modality from the wall, go into your own switch, go from that switch to your laptop. What IP address would you set your laptop as? The PACS. The device we're trying to emulate, right? Because you could come into CT and add your laptop as an output. You could go into CT and do that, but that's a pain in the butt. And you may not have access or passwords to get into here. But the beauty of using the PACS settings is it's already configured, right?
Just plug and play.
Yeah, everything's already configured, it works. So you plug your switch in there and you set up your laptop with the PACS IP address, the PACS port number, and the PACS A title. Now, how do you send an image? Even if you don't know how to use the CT, you have to tech do it. Hey, send an image to PACS for me. So they're going to PACS, but in reality, it's going to go to your laptop.
So you must have a switch to do this one.
Or a crossover cable.
Crossover.
Or a smart NIC, which will do auto crossover for you. Because if you crossover cable for, you probably have, NIC cards have 8 pins, positive transmit, negative transmit, positive receive, negative receive. NIC cards share the same pin configuration. So positive transmit the same line, that doesn't work. The crossover cable switches transmit and receive, or switch does that as well. So if you were to connect a NIC card to a NIC card, you would need a crossover cable because the transmit lines are tied to the transmit lines. The win. The switch will cross it over, or a crossover cable will do that for you. So yes, that's a good point.
The must have.
Yeah, and what I carry around now is on Amazon for $2.
So it's literally adapters?
Yeah, RJ45 crossover adapter. So now I carry a 20-foot straight cable with me, and then the crossover adapter, so you can do basically any scenario with that.
And no more looking at, it's like, is this a crossover one? Or that's why I started carrying those.
Does this make sense?
Yeah.
So in this case, you're going to use a JDICOM program called Image Server GUI, because that's going to be the SDP provider. And again, I kind of walk you through the same settings. The only thing you have to do in here, which I mentioned in the SDP file set tab, you can actually configure the path. So if we receive an image, it'll show that, which is not cool. So if you send an image from a CT to your laptop and you configure this directory, there'll be a DICOM file in that directory, which you can then look at the DICOM viewer, view the header, and analyze, which is nice.
And I go through the same thing. And the last slide here, as an overview, emulators are programs that allow our laptop to act as a DICOM device on the network. The laptop actively participates in the DICOM communication, meaning it sends or receives. We have a 2-week PACS class. We do some really advanced troubleshooting stuff. We get sniffers as well, where a sniffer is a device that will listen to a communication and analyze these PDUs. The beauty of that is we're not involved in the communication at all. We can listen to it and sniff between them and analyze it. That's a whole other topic. You cut the problem in half. Check the SCU side, check the SCP side, check the logs as a whole. Obtain a record of what is actually happening. You can send the logs to PACS admins, vendors, tech support. If you guys can capture that stuff from JDICOM, even if you can't read it, if you email it to me on the phone, I'm going to walk you through what's going on, look at this, check these PDUs. Obviously, we offer other classes, 2, 3, and 2-day, 3-day classes, and 2-week classes. They go really more in depth into this to stand alone. But I'm happy to help you. Then you can utilize more advanced techniques that we'll have time to cover. You can try different, CT, then do 3D, tonal, start recording. You can try compression, no compression, little ending, big ending. You can change all of this stuff. The things that we were talking about here were just kind of basic setup, make sure it's working. And now when you're really troubleshooting, you can configure all that stuff and see what works, what doesn't work, check performance, that kind of thing.
Very cool.
Makes sense? Okay. So if you want copies before you guys leave, again, this is a more granular step-by-step for DVTK. You can grab one of these. And this is the same thing for JDICOM. And if my auto out-of-office response didn't give you the download, I will check those when I get back. I'll send each of you the download. Okay. So I appreciate your time. We'll our chat with the Zero Hall from 4:30 to 6:30. So I'll see you guys around. I appreciate your time.